Hello viewers, so we have this question under organic chemistry. It says write geometric isomers for each of the following and assign E and Z configuration. Now to answer this question, we need to understand what geometric isomers are. So for instance, if we have two or more compounds that differ in their relative arrangement of atoms in their molecule, those are said to be constitutional or structural isomers. Now, these same structural isomers or constitutional isomers are what we call geometric isomers too. So these are basically compounds having the same chemical formula but different structural formula. So let's look at the first one. The first one, we are given to say we have carbon that is connected to another carbon. The carbon here is holding a chlorine atom. The other side, we have an ethyl group, which is C2H5. Then on the other side, we have bromine, and we have an OH on the other side there. Let me just write that. We have an OH this side like that. So the first thing we're going to do is we're going to find the isomer for this compound that we have here. To find its isomer, all we have to do is just switch one side, and then that will be the other compound that we can form from this. So I'll switch the right side, and I'll say this is going to be in this format now. I'm leaving the right side the same way it is, and I'm just switching the left side. So I'm going to put OH this side down here, and I'm going to put my bromine atom on top there. So this is what I've done here, and you can see when you compare the first structure to the second structure, let's call this one structure number 1, and let's call this one structure number 2. So when you compare the first structure to the second structure, you find that they are different in terms of their atom arrangements. On the first one, on the left side, bromine is down. You can see it's down here, and the OH is on top there. On compound number 2, the OH is down and the bromine is on top here. So for simple structures like this that only contain 2 carbons, and these 2 carbons holding the functional group are having different groups connected to them. These ones will basically just have 2 isomers. Okay. So there will be just 2. As we can see, we have 1 and 2 isomers. So if you have a simple compound like this, 2 carbons holding a functional group, and then a double bond, and then those carbons are also connected to different groups. It means they are going to only have 2 isomers for that one. And that will be the E and the Z isomer. So let's give them configurations now. How do we give configurations? So to give configurations, we basically need to give the groups that are connected to each carbon priorities. How do we give priorities? We give priorities according to atomic numbers. The atom that is connected to the carbon holding the functional group with the highest atomic number, that would be the one we're going to prioritize or give priority. So let's start. We have on this carbon here, carbon number 1, let's call it carbon number 1 and call this one carbon number 2. On carbon number 1 here, we have chlorine and we have an ethyl group here. So our main concern is what is connected direct to this carbon here. On the upper side, we have chlorine connected direct. Chlorine has got an atomic number of 17. Then down here, you see that this is connected direct to a carbon. Carbon has got an atomic number of 6. So between 6 and 17, we understand 17 is bigger. So this implies to say our priority group here is basically chlorine. So that's the one we have on the right side. On the left side, What we have is bromine that is connected to the carbon directly, and we also have oxygen that is connected to the carbon directly. Between bromine and oxygen, bromine has got a higher atomic number. So in this case, our group that we'll choose here will be bromine. That's the group that is going to be prioritized. So it means we have that here. So now, how would we give E or Z? How do we not say this is E configuration, this is Z configuration? So if you have your groups being on the opposite sides, the way it is on this one here, the first one here, we have bromine, our group of interest here, and chlorine, our group of interest on the other carbon, are on opposite sides. So if you have them on opposite sides, what it implies is what you have is an E configuration. So that's E isomer. It's an E isomer if you have your groups of priority to be on opposite sides. It's a Z if you have them on the same side. So now it means between these two, one is E and the other one is Z. Automatically, this becomes the Z isomer. But then you will also prove that. Now, when you look at this one here, what we have is already we are still comparing the same thing. So automatically, we not say chlorine is higher here in terms of atomic numbers and bromine is higher in terms of atomic numbers. We can see bromine is on the same side as chlorine because these groups that are connected to the carbons holding the functional group um, are on the same side. What we are going to do is we're going to say it's a Z isomer because of that. So whenever you have the groups that are groups of priority or the groups of interest being on the same side, it implies to say you have a Z isomer. If they're on opposite sides, it implies to say you have an E isomer. So yes, one, we have drawn the isomers, isomer number one, isomer number two. We found that isomer number one is an E isomer, and then isomer number two is a Z isomer. Well, that's the first one. We'll go to the second one. All right. So the second one, the structure we have is we have C connected to another C. This C is connected to an iodine. This one is connected to CH3. Then we have a hydrogen connected and a chlorine on top there. So this is what we have. Again, to draw the second isomer, what we'll do is just switch any side. I'll switch the right side this time. So we'll have our C. By the way, you can switch any side. You can switch any side and you're going to have your isomer. It's too correct. You are not restricted to a side that you can switch in this case, so you can switch any side. So I'm switching the right side. Let me just get rid of that. Yes, so I'm switching the right side. We're going to have a CH3 here, and we're going to have the iodine here. So already I have my two isomers. For this one, isomer number one, and we'll call this one isomer number two. All we have to do is just to know if we have a Z or an E isomer. So let's quickly do that. Let's look at the first one. The first one, this carbon here, let's call it carbon number one again and call this one carbon number two, is connected to iodine on top and is connected to carbon down here. So now between iodine and carbon, when you check on your periodic table, iodine has got a higher atomic number compared to carbon. So our group on this side is iodine. Here we have chlorine and we have hydrogen. Hydrogen has got an atomic number of 1, so this one has got 17. Already it becomes our interest, of interest. So now we can tell to say the group of interest are all on the same side. It means if they're on the same side, what we have is a ZD configuration. So this is a Z isomer. And then I know for sure to say after switching on the other side, we are going to have E isomer. But you need to confirm that. You need to confirm it. So we can see the groups that are of interest. We have chlorine here and we have the methyl group there. They are on the same side. Sorry for that. They are not on the same side, but they are on different sides. It's not the methyl group, but the iodine group. So the iodine group and the chlorine group on opposite sides. This implies to say we have E. Right. So that's what we have. Let's go to the next one. All right. So the next one. Now, when you're given a straight chain like this one here, all you have to do is start by drawing the carbons holding the functional group. So we have these two carbons here. Holding the functional group we're talking about is the double bond. We are considering the double bond in this case, not any other functional group, but the double bond. In order for us to assign the E and Z configurations, our main interest are the carbons holding the double bond. This is the functional group referring to. So start by doing that. We have those two carbons, this carbon here and this carbon here holding the double bond. Now, those two carbons are connected to a hydrogen each. So I'm going to connect a hydrogen randomly. So I'm connecting this hydrogen on top. I've decided to connect the other one on top again. That's by choice. I can connect the other one down here. It's still okay. Then after those hydrogens, you find that the group on the carbon on the right side is holding a CH3. Is holding a CH3. This carbon here after the hydrogen is holding a CH3. That's the carbon on the right side. Then on the left side, the carbon is holding this group starting from here up to this part here. So a CH2 and a CH3. So that's what we are going to bring here. We'll have a CH2, CH3. That's an ethyl group. So yeah, this is what we have in this case. All right, so now our job is to look at what we have and see which one is our group of interest on each side. So on the right side, we're going to call it carbon number 1 again and call the other one carbon number 2. So carbon number 1 and this is carbon number 2. On carbon number 1, we have a hydrogen connected direct to the carbon and also a carbon connected to uh, the carbon of interest. So now, between hydrogen and carbon, carbon has the higher atomic number. So this group here is our group of interest on this side, this group. Then here we have this hydrogen connected and we have this carbon connected direct. Again, between hydrogen and carbon, carbon has a higher atomic number. So this is our group of interest here. So the first one I've drawn here as the priority groups on the same side. That implies to say we have a C isomer. And then we can draw the other isomer here. All we have to do is just switch one side. I'll switch the left side. So we'll have carbon and carbon there. I'll put the hydrogen here instead and put the CH2, CH3 there. Then on this side, I'll leave them the way they are. I have my hydrogen and have my CH3 here. Again, we can see our groups now. The group of interest is this one, and the other group of interest is that one. So these are on different sides, and this makes it an E isomer. So that's an E isomer that we have there. So it implies to say we have drawn the two isomers and we have basically given them the configuration, which is E and Z configuration. So let's look at the last one. All right. So the last one that we are given, get rid of that. The last one that we are given is, again, we'll start by taking the part that is holding just the functional group. So we're going to say we have a C that is connected to a C. Now the C on the right side is holding a chlorine on top and is holding a bromine down here. I'm not putting this by guessing, but it's what we are given there. So the chlorine, the bromine is down, meaning the chlorine is the one on top. On this side here, the carbon is holding hydrogen. Now this one, I will put it random. So it will be down there, and then the CH3 will be on top there. Yes, so that's what I have for that. So have a CH3 on top, a hydrogen down here. We can draw after doing this, we can draw the other isomer, and we'll just say we have C and C. We are switching one side. I'll switch the right side this time again. Put an H there, put my CH3 there. And then on this side, I'm going to switch them. Put my bromine here. Put my chlorine down here, and then I'll put. So yeah, that's what we have now. So we have the two isomers. All we have to do is assign them as Z and E isomers. So starting with this one here, between bromine and chlorine, bromine has the higher priority. And then between hydrogen and carbon, carbon has the higher priority. So the first one, the two priority groups are on opposite sides. This implies to say we have an E isomer. So this is an E isomer that we have here. On the other side, the bromine and the methyl group are on the same side. So it means we have the C isomer. So this is how we assign the E and the Z configurations, and this is how we come up with our isomers. So the key points to take is if we have a simple molecule that has got basically simple structure like what we have here, where two carbons that are holding the double bond are connected to different groups. It means we're going to have one C isomer and another which is the E isomer. We're just going to have two isomers for each of them. Thank you.